Today's lesson is called Comparing and Ordering Rational Numbers. In today's lesson, we're going to learn what a least common multiple is and how we can use it to compare and order fractions. So first off, we're going to be learning what LCM stands for. LCM is a least common multiple, which is the smallest number that a set of given numbers divides into evenly. So, for example, if I give you 2 and 3. We're not looking for the greatest common factor, because the greatest common factor is actually 1, because 2 times 1 gives me 2, 3 times 1 gives me 3. They share 1. But that's not what we're looking for. We're looking for a number that they divide into evenly, and it needs to be the least. Least means the smallest. So if I look at 3 and 2, while my least common multiple would actually be 6. Why? Because 2 divides into 6, see, 3 times, and then 3 divides into 6 2 times. So 6 is a number that they can both divide into evenly. So make sure you have the definition of the least common multiple. Now there are two ways to find the LCM. The first way is you can make a list of all the different multiples, or another way of using it is the prime factorization. We find all the common factors plus all the remaining factors. So make sure that you have the two ways that we can find our LCM. It's up to you which way you prefer. So in your notes, I want the directions, make a list of multiples, and go and write down number 1. Write down the directions as well as number 10 and number 12. I want that all in your notes. So when they ask for multiples, what we're doing is we're trying to figure out, okay, so what is 10 times 1? 10 times 1 equals 10. So my first multiple of 10 is just 10. Then my second multiple was 10 times 2. That'd be 20. 10 times 3, 30. 10 times 4, 40. So all you're doing is taking your number. In this case is 10. We're just doing 10 times 1 gives me 10. Then 10 times 2 gives me 20. Oops. And then 10 times 3 gives me 30. Those are the different multiples. Basically, you're just starting with 1, go to 2, 3, taking the number and multiplying it. So if we keep going, we have 10 times 5, which is 50, 10 times 6, which is 60, 10 times 7, which is 70, 10 times 8, which is 80, 10 times 9, which is 90, 10 times 7, which is 100, and we can keep going on and on and on. Remember, our whole goal is to find the C. We're looking for what they have in common. So I find all the multiples of 10. Now it's time to find the multiples of 12. So let's say 12 times 1 is 12, times 2 is 24, times 3 is 36, 4 is 48, then we get 60, and if you notice, they have 60 in common. So my least common multiple is going to be 60. So I want to try to find the least common multiple of number 2. What's the least common multiple of 32 and 40? So on your own, go and try to figure out. Least common multiple of 32 and of 40. So first off, you should make your list. So see, 32 times 1, 32, times 2 is 64, times 3 is 96, times 4 is 128, times 5 is 160, times 6 is 192, 7 is 224, see, 8 is 256, we could go on and on, so let's do our 40s. So 40 should be easier. So 40 times 1 is 40, times 2 is 80, 3 is 120, 4 is 160, and if we notice, we have 160 in common, so in your notes, you should have gotten the least common multiple equal to 160. Now, the second way is we can use prime factorization. So I want this in your notes, I want the directions as well as number 18 and 20. So let's go and practice our prime factorization. So remember, you can choose any two factors. But with 18, I always think of 2 and 9. And automatically I know 2 is a prime number, so I go ahead and circle it. Then 9. How can I break apart 9? 9 can be broken apart into 3 and 3. And once again, I know they're prime numbers, so let's go ahead and circle them. Now let's worry about 20. Let's see, with 20, and let's write down our primes. So, sorry ladies and gentlemen. So I had my 2, that's where my 2 came from. My 3, that's where that came from. Other 3, that's where it came from. So if we test this out, 2 times 3 is 6, times 3 is equal to 18. So that means I have all my prime factors. Now we work on 20. So when I think of 20, I think of 2 and 10 first. So 2 is my prime. Let's see, 10 I can break apart into 2 and 5. 2 and 5 also happen to be prime, so go and circle them. So then I'm going to list my primes. Remember, prime factorization. We are factoring, and we should end up only with prime numbers. So that's where my 2 comes from, my other 2, and my 5. So, if you look in your notes, how do we use prime factorization? So first off, we select all the common factors at once. So in your notes, I want the sentence, select all common factors once. So what do we have in common? We have 2's in common. So I select my 2's. So common factors are 2. Then, what's my next step? Then you select all the remaining factors. Go and put that in your notes. So, selecting common factors, put a little arrow, that's where you got your 2 from. So make sure you know where your common factors are coming from. Now, we have to have our remaining factors, our leftover. So don't forget about your leftover. So I have a 3, that's where my 3 comes from. I have another 3, that's where my other 3 comes from. I have a 2, that's where my 2 comes from. And I have 5, that's where my 5 comes from. So I had my leftovers. I had my 3 times 3, which popped up right over here. 2 times 5 popped up right over here. We start with what they have in common, then our remaining. Then all we do is multiply them. And when we multiply them, I get 180, and that will be my least common multiple. Now, on your own, make sure that you write the directions one more time and try to see what's the prime factorization of 45 and 72. So let's see, for 45, the first thing I think of is 5 and 9. 5's a prime, so I circle it. 9 can be broken down into 3 and 3. So go ahead and circle both of those because they're both primes. Then with 72. Oh, sorry, don't forget to list them. I'm sorry, ladies and gentlemen, I keep forgetting that. Don't forget to go and list your prime factorizations. 5, 3, and 3. So my 5 came from there, 3, and 3. Now let's worry about 72. So 72, I break it apart. I get 8, and I get 9. 8 I know can be broken apart into 2 and 4. 2 is a prime, so let's circle it. 4, I can break it down into 2 and 2, both primes, so I circle. Then 9 can be broken down into 3 and 3. And then all your prime factors, oh sorry, don't forget to circle them, and all your prime factorizations should be there. So don't forget to remember, guys, we're looking for primes. So all these are prime numbers. Then what's your next step? Your next step is to select all the common factors. So what do I have in common? I have my 3's. So my least common multiple of 3 times 3 comes from there. So make sure you're noticing, hey, these 3's come over here, these 3's, same came over here. These are what I have in common. But now I also have these leftovers. So what do I do with my leftovers? Then you select your remaining factors. So what's left over? I have my 5, so my 5 goes in my answer. I have a 2, 2 goes in my answer, the other 2, and one more 2, and then I multiply it all together, and what's my answer? I get 360. So, little reminder, so no one is left behind. Don't forget about your remaining factors. Don't be like, oh, my common factors, I'm good to go. You still have remaining factors. No one is left behind. Now, going to write your directions one more time, and we're going to be dealing with a variable. Remember, I want you to treat variables like numbers. Don't be scared of them. Treat variables like numbers. Okay, so with 12. First, I always break it apart. I get 12, whoops, that's supposed to be 2, and I get x. X is a prime, so I'm just going to circle it. Just can't simplify that any farther. Let's see, with 12, I think of 3 and 4. I know 3 is a prime, so I go and circle it. 4 can be broken up into 2 and 2, all primes. So then I go and multiply it, so I get 3 times 2 times 2 times x. Then look at my 40. Break it apart, I get 40, I get y. Y is a prime, can't get any smaller, so I go and circle it. Let's see, with 40, I think of 2 and 20. 2 is a prime, so go ahead and circle it. And then I get, let's see, 2 and 10. 2 is also a prime again, so I go ahead and circle it. And then 10 can break apart into 2 and 5, both primes. So go ahead and circle it. So then I end up with, let's see, 2 times 2, oops, times 2 times 5 times y. So what is my least common multiple? Let's see, well, what do they have in common? They have a 2 in common, 2 in common, so I go and put a 2, another 2 in common, a 2 in common, another 2. They have nothing else in common, but remember, we have our leftovers. So I have a 3, times it by 3. Have an x, times it by x. I have a 2, times it by 2. Have a 5, times it by 5. And I have a y, times it by y. Sorry, I ran out of a little room, so I went ahead and moved it. So now I have all these numbers. What do I need to do? I need to multiply them. So I have 2 times 2 times 3 times 2 times 5, which will give me, so I have 4 times 3, which gives me 12, times 2, which gives me 24, times 5, which gives me 120. But I also have an x, so x comes on the side. I have a y, comes on the side. So that is going to be my answer. Don't be scared of the variables. They just come along for the ride as well. So what is LCM used for? What is least common multiple used for? Well, it's used for to find common denominators so that fractions can be compared, added, or subtracted. So I would like this in your notes. The question as well as the answer. So in your notes, go and write the direction. We're going to use the less than or greater than sign to compare the fractions below. We're just going to focus on number 1 for right now, so make sure that's all in your notes. So looking at number 1, we have to find the least common denominator of 5 and 7. So if I do 5 and I do 7, prime factorization, I get 1 and 5, 1 and 7. So then, what do they have in common? They have 1s, so I put equal to 1. My leftovers times 5, leftover, times 7 gives me 35. So now my new denominator is going to be what? It's going to be 35. So now let's see what happens when I change it to 35. So then I know that my new denominator is going to be 35. Remember, if you do anything to the denominator, you do it to the numerator. So how do I get 5 to 35? I multiply it by 7. And remember, technically, 7 divided by 7 is equal to 1, so we're only multiplying it by 1. Remember, we're manipulating again, so I think it's going to happen on this side. Well, on that side, how does 7 turn to 35? We have to multiply it by 5. Oh, sorry. So 7 times 4 is 28. That's how we get our new numerator. Now, for our 5/7, I multiply it by 5, and this will turn into 25. So remember, these are equivalent fractions. 4/5 is the same next thing as 28 over 35. And then, 5/7 is the same exact thing as 25 over 35. They are the same. We just multiplied this one by 7 and 7, multiplied this one by 5 and 5. They are the same. Same and same. Equivalent fractions. So now we can properly compare it. So should I be putting a less than or the greater than sign? Well, 28 is way bigger than 25. So 28 over 35 should be greater than. Now, go ahead and try to do number 2 on your own. So looking at number 2, automatically you should notice, hey, I have an 8 and I have a 16. 8 times 2 gives me 16. 16 times 1 gives me 16. So my least common multiple should be 16. That should be a gimme. Automatically, if you know your times tables, 8 is connected to 16. So, I know that my new denominator is going to be 16. The question is, how do I get there? For the 8, I have to times it by 2. What's 2 times 5? It gives me 10. And then how does 16 become 16? Well, we multiply it by 1, so we end up with a 9. Now we can compare it. So is 10 less than 9 or greater than 9? Well, we know 10 is bigger, so it should be greater than. So I know that 5/8 is greater than 9/16. So now I'm just going to write me a 2-sentence summary. We learned about least common denominators, least common multiples. We use it to find denominators in order to compare fractions. So what are the things you learned today?